Hey guys, welcome back to the Geography Academy. Remember, this video is just a small part of a much larger course that's available below if you just follow the links and instructions. Okay, this is part 2 of coastal environments. We're looking at coastal landforms. This is going to be a long section and I'm also going to go through it quite quick. So make sure you stop, you understand everything fully before moving on to each section. This does take quite a long time when you're learning it for the first time. We're going to look at landforms in this section. We're going to start off with a headland and bay. We have the discordant coastline here where we see alternate bands of hard rock and soft rock. Here's our ocean. And what's happening basically is that the soft rock, like a clay, is going to be eroded fast. And the hard rock, which is, let's say, something like a granite, like intrusive igneous, is going to be a bit more resistant then to the changes. The soft rock then is eroded much quicker. At this point, you can bring in your answer the definitions from the previous one, which is hydraulic action, abrasion, solution, how that works to erode away the softer bay. And then we see the headland formation. So this is jutting out into the sea, and the hard rock is left to jut out into the sea. They're exposed into the full force of the wave, and they have rates of erosion increasing due to wave refraction as the wave bends around the headland. So we can see it here breaking the energy and causing refraction, or the change of the wave direction. Now this will reduce the force of the waves and it will definitely dissipate their energy, which will then in turn lead on to the depositional feature, which is the bay. In this case, we can see the bay forming. We have the waves lose energy and will be transporting sediment. The sediment has been eroded from the cliffs. It's been broken down through attrition and will be transported until it breaks in the shoaling process, and this forms a bay through deposition. So there you go, a lot of the keywords from the previous section. So if you don't know those keywords, it's difficult to keep up. Make sure you learn those first. So in total then we're just going to go through a step-by-step process of each one just to ensure that you can then explain it in a couple of points, making sure you have a chance then to bring your vocabulary into it. Flamborough Bay and Swanage Bay, or Flamborough Head and Swanage Bay, are two examples there, where we have then the headlands and bays. Here we see a good example of it here. So if we're following the same logic and we believe that it's the same type of makeup of a discordant coastline, we would say that the soft rocks are in between bands of hard rocks starting here, and we can see it forming a more distinctive sort of a hill all the way down a particular type of geology there. So that would be our hard rock there. So it's sticking out in this area here, and as the waves are coming in, we would find that some of it's going to refract around and it's going to aim for this area here and cause erosion. We can see a little indent in it over here, for example, and it's even pushed its way through this part here, which is going to disconnect some of the headland from the rest. Now the bays, we can see there is a gradual dissipation of the waves because of the change of color there. We can imagine the depth is changing, although I'm sure it still has some force there, but overall then it's going to cause deposition and a bay to form in this area. Okay, wave cut platforms or coastal platforms then are looking at more of erosional features rather than deposition. We talk about the high-low tide mark. In between this area then, especially towards the high tide mark, we see a greater level of erosion. This creates then a wave cut notch. So this is the point where you explain the different types of erosion. So hydraulic action to open up the cracks, and abrasion then to increase the rate of erosion. That's going to create the undercut here. And yeah, this will explain the base. Now the undercut increases what we call the shear stress on this point. Okay, so now we have shear stress brought into it. You might remember that from last year studying mass movement. The shear stress then added into that point. So all that weight then is added in there due to erosion. So this is undercutting and increases shear stress and increases the chance of a mass movement or a fall off the cliff. The subaerial processes that could be going on could be carbonation and root action, for example. So as water seeps into like chalk or limestone, it's going to dissolve with acidic rain. It's going to dissolve the calcium carbonate, for example, out of the limestone and weaken the structure within. Meanwhile, we might have a tree on top, and that tree has roots, and that may be causing root action from above. So these processes then are weakening the interior of the cliff, and we would talk about that as weakening the shear strength, so the cliff's ability to hold itself up. So this is how we talk about mass movement. It's the adding shear stress, weakening shear strength, interrupting or disrupting the equilibrium of the cliff to hold itself up, and therefore it will collapse in one mass movement here, which would be quite a large rockfall. In the previous unit, then, we discussed how this could be influenced by the different types of geology. So it's a good thing to go back to there and talk about, if you wanted to include the influence of geology in this perspective, you could talk about if it was a seaward dipping bed plane, for example, like we talked about at the end of the last unit there, and include